No, no, we can even discuss tonight. I mean, and it's not that I am a strong advocate for that, but sorry. Oh. Well, first of all, my apologies for starting late. I don't know why I was completely. I was taking it easy because I was sure we had to start at 3:30. No, 3:30. So I was just letting time pass. So well, this is Nfvrg. Just welcome. This is the node well adapted to the IETF conditions. This is the again. This is not working well. No, right? Yes. These are the is a usual call for document review and the data about the site, about the list, the group, etc. Things we have Pedro taking notes. A second note taker that connects to the Etherpad will be really appreciated. So we have and we have Evangelos somewhere there acting as a Java scribe. Well, the usual call about the research-related events. Whenever you know about anything, just tell Ranky or myself. We're happy to help. And a few comments on that the GAPS draft, the one that was went through last call inside the group, is under IETF chair's revision, and she, according to her notes, She will be then ready to be sent to the IASG for conflict review. There was an interim meeting on model-driven optimization. There was a quite good participation, a remote participation, but just in case you have the report and the presentations in that link. And well, there is a proposal that was discussed to specifically consider network slicing among the group work items. I know that this comes after some BOF on network slicing precisely that was with results that were somehow not very much welcome by part of the community. So, well, let's see what happened after the presentations today. Many of them, 2/3 of them will be dealing with network slicing. And, well, something that we should have to address later on in the, not today, but on the list, etc., is about the concrete matters, is something whether a particular aspect is believed that belongs to the discussions on the discussion of the Nfvrg group. And on the other point is about whether network slicing in general should be a specific work item for Nfvrg. And well, no more, this is the agenda. We start with these reflections I'm making. Then we will go on update on one of the proposed drafts on intent and how this connects with the energy orchestration frameworks. Then we will be talking about discovery mechanisms, and then the rest is the other 4 presentations that will be, I hope, brief enough just to cover less than 1 hour on network slicing. I don't know if you want to add anything, Ranky?
Yeah, so what I really want to add is we need to, we're looking for more traffic in the list. It's been quite late. So, as Chaz, we're really looking for more traffic in the list, especially after the model-driven optimization. There was a lot of interest in discussions, the interim meeting, but we're hoping there are more discussions on the list, but it quietened down. So we'd really love to see more, discussions. Yeah.
Okay, so let's start. Pedro, you are the next one. I hope everything will go well when it comes to. So.
Hi, good morning. Good morning. Pedro Aranda, currently Universidad Carlos III. This is an update on the work I've been doing on recursive NFV definition. It works. So since the last IETF, what I did was corrected minor typos. Thanks for the pointers. And since it was requested, I added a section on operational experience, which I'm going to be elaborating a bit right now in this talk. So based on real life experience, we have a project called MAMI. There you see the logo of that project in the upper corner. And on that we are doing NFV stuff as a way of experimenting on middle boxes. And it's in that environment that I've been doing quite a lot of stuff. So the network service I based this thing upon is a bunch of NFVCs that help us characterizing the IP performance of 5G enabled networks. What have I touched? Okay, so we have two components that are based on Traffic, which is a traffic generator, which is actually wrapping on top of IPERV3. Then I have a database to feed data from the measurements that's based on InfluxDB, and then I have a traffic sniffer that is based on T-Shark. So a nice thing about this environment is that depending on what you want to do, if you have the VNFs, the traffic VNFs, what you're going to have is add whatever you need for your particular environment. So we start with something like this. You have a client and a server and the network you're testing there. And then it can go to, well, of course, better if you also have the database to collect your measurements, because afterwards, the data from the InfluxDB match very well into anything, any kind of report you want to do. Can be even better. You can also mix in a T-Shark, a Wireshark, a traffic sniffer, and you can, instead of getting the results from the measurements you get from Traffic, you can also go directly into the packets and analyze the packets to see your things. And to make things complete, you can also have everything. Here you have 4 possible network services, which are, if you look at them, they are incremental based on the network service you have there at the top right from your side. So, main problem is all these things, if you go in your system and you want to do it using the manual stack you have, will be normally written in YAML. However, the experience I'm showing here is that's much better to have everything written with NeMo. It's like this question of, in the 80s of the last century, it was still part of the cool stuff to write assembler, but it's you started to have other wonderful high-level programs to do real programming. So in this version of the draft, one of the things I'm showing is how to use NeMo to build things incrementally. Incremental YAML is sort of complex because you have to put many different little lines in very specific parts of your network service descriptor. While if you do it incrementally with NeMo, it's take what you already have and put things on top of that. There are a couple of examples of this in the draft. And since it is what you have is not touched and what you put new comes incrementally into it, and it's a high-level language that you can really read and you don't have to worry about having the right indentation, less things can go wrong. So another goodie, while working on this, we had another goodie, NeMo. For those who recall previous versions of the draft, have 2 things. One is the node models, and the other thing is the link models, where the node models are used to express the virtual network function components, and with the link models, you can express things like the network service graph. So you have something like this here, in this case, the sniffer. When you put the sniffer, and we've been starting to see that mono infrastructures support things like, are starting to support things like tabs as a service, for example, in OpenStack. So you could actually extend even the link model. Currently we have point-to-point and ELAN or VLAN. You can go and add a third link model that implements this tab as a service in order to do this, instead of having to write lots of things and putting even a hub outside the network to do the sniffing. So this is something that is already available in OpenStack. So one of the things that's currently being part of the work is once the mono we are using, which is OSM, has a notion of this tab as a service plugin in OpenStack, we're going to be adding the link model, the specific link model that implements sniffing. So, conclusion, it's a 6th round of the draft. We have included all the corrections from previous critical readings, and I want to thank again here all the people that took the time, read the previous versions of the draft and sent comments. Included the operational experience as requested in London. So Just a question and a request. I think we should move this forward and have it part of research group adoption. So I would ask for research group adoption of this draft as it is now. And that's it.
Thank you. So that's time for questions and comments.
So this is very interesting, especially the modeling aspect. So one thing we want to take a look, there is some work happening around network service mesh, which is trying to abstract sort of the different physical, basically hardware representations. For example, you have InfiniBand, or you could have, different types of transport, right?
Yeah.
So rather than right now, the approach is you expose physical interface network functions, and they're all synonymous to the hardware implementation. Instead, network service mesh is looking to abstract those sort of in a more developer-friendly way. It's something perhaps we can take a look, right?
Yeah.
See if we can benefit.
Of course, the only thing is that this link models we have right now, if you go, it only has point-to-point and LAN, which is everyone with everyone. So it's already abstracting whether that is a VXLAN or an OVS or whatever. So I think this is already there. The only thing, when it really makes sense to have a new link model is for things like this sniffing, where you actually have a tap as a service, which is neither an ELAN nor a point-to-point. So we are doing this from the very high level already. So I think it's already there. So
this is perfect. Then maybe we should synchronize the work, this and the other.
Okay. Yes.
Yeah, the other way to look at it.
Yeah.
Thanks, Pedro.
Okay. Thanks.
Okay, so on the adoption, we will talk on this on the list.
Yes, please.
Okay. Thank you. So, Carlos, yeah. Let me try to see how I. So now it should be like this, no, like this and like this.
Okay, thank you, Diego. My name is Carlos Bernardos from UC3M, and I'm going to present some slides about discovery mechanisms in the ETSI NFV Mano stack. So the idea here is to basically present the problem, and then I will basically also present one example of solution that we have been working on, but this is just for the sake of presenting an example. The main idea is to present the problem and see whether there is interest in the room for working in this kind of issues. So this is the outline of my presentation. So first, a very brief motivation of why we need discovery mechanisms and why, or what I understand by discovery mechanisms in the ETSI NFV Mano stack. Then we will basically try to identify in the Mano stack where we need these discovery mechanisms. There are like 3-4 reference points there that are identified by ETSI that require this kind of discovery mechanisms, and then I'm just focusing one of them, the RVI, where is I think the one that is relevant for the kind of scenarios that we are at UC3M particularly working on, and I will present an example of solution based on IPv6, but this is just an example as I mentioned before. And then some conclusions and next steps. So motivation, I always like to try to use a Dilbert strip for this kind of motivation. I think this is clear. ETSI NFV or NFV is no longer something that will happen in the future. Network function virtualization is something that is happening today already. But it's also true that today is something that is mostly limited to data center environments. So, and by data center environments in the scope of, or in this talk, basically I refer or I highlight the characteristics that is a semi-static environment, where all the entities that are there are pre-configured and all the entities that are involved already know the other entities that they will interact with. But this is not the only scenario that we can consider. Well, before I go into other scenarios, this is an example of what I mean by data center environments. This is a figure taken from one white paper, and it's basically showing the Unica architecture or the Unica vision, which is from Telefonica, but this will apply to many other companies, where basically in the vision that they have in how to use network function virtualization in the end-to-end services, you have data centers that may be centralized in in regional data centers or closer to the users in local point of presence, but at the end of the day, they are data centers that are very, very static. They are there, you have your infrastructure, and basically we are talking about racks and infrastructure servers put there. But this, again, is not the only potential deployment environment for network function virtualization. Another one is what we call this edge fog dynamic environment. Basically, is where we put or we push the virtualization closer to the users in like micro data centers that are in the premises of the user or even at mobile devices. We may think of a car, or we may even think of a mobile phone as a device that may host virtualization resources and even an NFV kind of monostack on that. And this is what we refer to the fog. And then we have this continuum from the fog at the very edge of the network, even at the end user devices, to the centralized cloud, the typical cloud that we are more familiar with. So in these scenarios where we have these resources on the end devices, these devices may move, may appear and disappear, so it's volatile, dynamic. In those cases, we really need to have mechanisms to discover or to advertise what are the resources that are available. So the involved entities can know that they are there, that they can interact, that they can engage into a relationship, and what are the resources that they offer, what are the resources that are behind those entities. So this is something that has been already identified by ETSI, for example, in some of the specs, or in IFA 28, for example, for multi-domain, but in IFA 5, they also discovered that, for example, between an NFVO, an orchestrator, and a VIM, and the resources, this relationship is now assumed to be pre-known, pre-established, but there may be environments where you may need to have discovery mechanisms for those. So this is one example that we will talk about more later. Trying to basically illustrate in a picture what I meant before by this distribution of or use of availability of resources at the edge. Basically here we have a picture where we have the data centers, centralized data centers. We may have virtualization stuff at the transport of a mobile core environment. So really close to the, closer to the end users, but we may have also devices here that are mobile, appear and disappear, where we may have virtualization resources, where we may be running DNFs. And those things may host BNS, may host part of the monostack, and as I mentioned, they can appear or disappear. So this is why we really need to have discovery mechanisms, because in these environments, we cannot assume that everything knows everything in advance and everything is pre-configured, because there are things that may appear or disappear dynamically. So that's kind of the motivation with a particular example, which is kind of dynamic distributed environments, the fog. This is not the only one. I will talk a bit more later about multi-domain, which is another environment or scenario that brings this need for discovery functions. But then let's take a look at the ETSI NFV framework architecture for NFV. This well-known one is not the only one that we can think of, but anyway, what I am going to present here will apply to other potential architectures. So where do we need discovery functions in this architecture? Well, basically, those are the main 4 points where we may need. So one is between an orchestrator and the VIM, so between an orchestrator and, at the end of the day, the resources that the orchestrator may control. These resources may not be always there where the NFVO is, for example, because of this mobility stuff. This is one point where we may need these discovery mechanisms. Another point is between orchestrators. If we think of multi-domain environments like the ones addressed in IFA 28, we may have different orchestrators involved, and we may need to discover those, and not only the availability or the presence of those orchestrators, but more importantly, what is available behind those orchestrators. So what are the functions, the resources that those orchestrators manage? So this is another point where we may need discovery functions. Another one is between the VNF managers and the VIMs. So you may have a VNF manager that needs to interact if operating in what is called direct mode to with different beams. So we may need to discover what are the beams that are available. And similarly to the ORBI, to the interface between the orchestrator and the beams, there is also, in the context of IFA28, in the context of multi-domain, the interface between different beams. And there may be also the need for discovering what are the beams that are available. So those are the main 4 points that we consider as potential targets for discovery functions. So I mentioned before that dynamicity fog environment is not the only use case for having this kind of need for discovery mechanisms. Another one is multi-domain. Multi-domain is basically the idea that we may have multiple administrative domains where we may make them collaborate in order to instantiate, deploy an end-to-end service. In order to do so, you need to have interactions between the orchestrators, this OR interface, or between beams, or a combination of both. In these scenarios, ETSI already identified that there are 2 potential options. Either you have everything pre-configured in advance, which may fit in several scenarios, but certainly not in all of them, or you may need to have some auto-discovery functions to discover what are these orchestrators, what are these functions that are available, and what are the resources that are behind those. So this is basically what we will also focus in the context of this talk. So we have identified 4 different kind of points where we need discovery functions. Not all of them have the same requirements, because not all of them require the same amount of information or the same type of information or assume the same pre-requirements. So here we list the 4 of them. So basically, for example, the OR between orchestrators, this is basically something between different domains. So here it's important not only discovering those, but mainly once you have those discovered, so they know that there is an orchestrator there, what are the resources and the functions that are behind those orchestrators or are controlled by those orchestrators. So if I'm an administrative domain and I want to deploy something that I cannot deploy in my own infrastructure because, for example, I don't have the geographical footprint that is required for that service, I need to understand if another orchestrator is capable of providing me that geographical footprint that I need. So I need to have the knowledge that the orchestrator is there first, and then the knowledge of what is that orchestrator can provide me in terms of functions that I can instantiate, like kind of a VNF as a service thing, or resources, kind of NFVI as a service that I can use to instantiate a service, or as part of a service that I'm instantiated with resources in my infrastructure and in other infrastructure. So this one kind of requirements. In the VI VNFM, the requirements are a bit different because in this case, this is a VNFM, probably this is basically intra-domain, so I don't need to have the discovery of other entities that belong to different domains, but we need to discover what are the VIMs that are available because I may need to contact them in order to scale up, scale out, instantiate, whatever functions on the resources managed by those VIMs. The ORBI, we will spend more time later, but this is basically the need for this is mainly, but not only, because of these dynamic environments that I mentioned. I may have an orchestrator, I may have several resources, but at some point in time, additional resources might appear or disappear. So I need to be able to discover that they happen, and also if new resources appear, I may need to, or I may want to know what are those resources that appear, and in case I'm interested in using them, in registering with them, do so. So it's not only about discovering that they are there, but also discovering what is available, what is provided by those VIMs. We will see a bit more in the next slides. And then the VI-VI is similar to the ORBI, and basically the needs for that is in the context of multi-domain, when you have a VIM implementing what is called the single logical point of contact. Basically, you have a VIM interacting with multiple VIMs and provided a single interface to whatever is above the NFVO. You need that VIM to be able to discover the other VIMs. So basically similar to the ORBI kind of requirements, but in the context of between different VIMs. So this is basically the general idea. Where do we need discovery functions, and why do we need those discovery functions? So now let's focus on one particular thing. This is the ORBI, and a sample of solution. Again, it's just an example. So the generic case scenario, or a potential example of the scenario that we have in mind. So we have an NFV platform, basically like a kind of data center that is available there. It's what we are used to, something that is kind of static. And then we have a resource that is mobile, or a device that is mobile, maybe a car, maybe a mobile phone, maybe something like that. That, since it's mobile, it may appear or disappear in the same network where we have the existing data center, existing NFV platform. And this device here may have available resources for others to use. And how do we make that happen? Today, we cannot do this with the existing standards because this interface is something that's pre-configured. This reference point is used to instantiate. It's used to query what is available, but before doing that, you need to have that relationship in place. So in order to extend this for a more dynamic scenario, we need mechanisms that allow this NFVO to know that this Vim is available here, that there are some resources that it can provide, and how this NFVO can actually get in touch or contact with this Vim and register. A bit more detail on examples of use of this. So this is basically what I mentioned before. We have a platform, existing platform here, where we have resources, services deployed that are consumed by somebody. Our service at the end is consumed by a user or an entity. And this platform may be extended by using resources from other devices that are mobile. So that's one particular example of applicability of this. We can also turn that around and think of the other way around, or the inverse scenario, which is where we have a platform, complete platform, so the consumer of the service is on the mobile platform, and that platform may want to use resources that are available in a data center that is available where the user device, the mobile device attached to. So this is another scenario, but it's essentially the same from the point of view of the mechanisms that we need. And then one particular solution that we are working on, and we have in this draft, this draft is only available 0.0, so the 0.1 version that we plan to submit in the next few days will include some of the solution that I will briefly introduce in the next slide, is where we have an IPv6-based approach, IPv6 environment, where we assume that devices may appear and disappear as a result of a device connecting or disconnecting from the network. And what we propose is to basically convey information about the availability, the system of this device, and the resources that they may have on IPv6 signaling. So basically what we have here is just an example. I will not go into the details, but it's basically using network discovery to advertise the availability of these resources. So in case that the NFV, the orchestrator, the existing platform really wants to use those resources, it can then talk to the Vim and register. So basically here is where we embed, extend, and ND signaling to advertise those resources and also the identity of the Vim. And then here we can do some registration of between the NFV and the Vim, so the NFV then can use the resources that are available at the mobile platform. So that's basically an example of an idea. Again, this is just one example. And what I'm more interested in is to know whether you think that this kind of mechanisms for auto-discovery functions in general in the NFV MANO stack are useful. I try to justify that are required not only because of fog dynamic environments, but also in data center environments because of the multi-domain aspects. NFV already identified this, but I'm not aware if they are really working on this kind of solution at this point. But they identify that in IFA 28, for example, they put this specific text that I put before, and whether you think that is something that we can continue discussing in this research group. And that's it.
Thank you. Please don't look at me. Just go to the mic.
No, I'm just saying if questions are allowed now. So,
No, not from you.
okay. Thank you. So, Evangelos Haliplidis, Mozadat Networks. So, I have two questions. Usually, for this draft, are you going to define some kind of data model of what kind of information is going to be discovered? Or, I mean, are you going to use some existing ones? And the second is, have you thought about any security issues that may arise by some rogue some element that's going to try and find out what kind of resources exist in already systems?
Okay, so thanks for the question. The first one, at this point, we are kind of trying to reuse the data model that sits in Nfvrg. So we're trying to use the same thing that, for example, in the RBI, there is something defined. I mean, in IFA 5, I guess, I don't remember the number, but there is, for this reference point, when you query the resources that are available, there are some models available there. So we are basically reusing that. If we discover by further developing this that we may need something else, yeah, I mean, for example, something that we need is this thing. I mean, this kind of thing is basically taken from existing NFV documents, but the point of conveying the URI to get to the BIM is something new, because in Etsy, this is assumed that is no in advance. And then on the second point, on the security aspects, that's a definitely very valid point. In the context of multi-domain, we have already some work done in different projects on what is required. In the context of this, but in this multi-domain stuff, typically you have some pre-relationship between the actors, the stakeholders, so you can rely on that. In the context of the fog environment, this is something that we need to see, because of course you need something, you cannot do whatever, you cannot expose everything to anyone. You can play with different kind of levels of granularity, you can play with exposing something very simple, and then depending on the relationship that you have with the other one, provide more details. So these kind of things are details that need to be worked out. Yes. Thank you very much.
Laurent Chavalia, Nokia. I have two questions. One is, you consider discovery. Have you also think about the other way around? I mean, to have self-advertisement of available resources or capabilities, so that you can have because if you do discovery, it's an active process. You want to discover something, so it can work in some situations. But you can also have the reverse situation, and you have self-advertising, so you know that some resources will be available when you want to compose them. So just.
Yeah, that's a very good point. Actually, probably I misuse the term discovery, because actually in the draft we cover both, but it's basically based on the advertisement. So we define some mechanisms for advertise. So you attach to the network and you advertise your resources, and then we also support somebody requesting the existing devices to advertise. That will be like kind of the discovery part. Like, okay, and there, please, if you have something to tell me, tell me. But it's everything based on the advertisement.
Okay, thank you. And second point is, I saw in your presentation that you consider different requirements of discovery for different interfaces or different situations. I get it. I saw also in different working group or research group that there is this, we still come back to this need of discovering new capability in the network. And you have a proposal here to piggyback on IPv6. But did you also consider considering a kind of generic approach to discovery, where you have you want to discover capabilities, and then you have a model to say that kind of what I'm looking for and what the network or the component can advertise. Because I see the need that in some other working group, we're also designing new discovery mechanism or protocols. So if you have one for NFV and one for Anima and one for others, so maybe there are some common needs, and having a more generic design, we can, I mean, profile some of the capabilities, or dynamically you insert what you are looking for.
Yeah, that's a good point. Definitely we need to look into that. This specific solution came from one scenario that we are working on where it fits very well, but I fully agree that it's good to look into other options and try to, I mean, have one single solution with different profiles instead of having like multiple approaches.
Okay, thank you
very much.
One last question. Very interesting topic. In fact, we're investigating this in ONAP in the context of Edge. So what we realized was, as we walked through the use case, especially the mobile VIMs, I mean, as critical as the network functions are, the application is the one which actually drive it. So sort of saying that, hey, I need AR, VR, like low latency in the edge, and then I need this, need to capitalize on mobile infrastructure, right? So that said, what gets interesting is, so how do you manage the separation of concerns? So for example, especially, you have a constrained Vim resource, few servers, then do you really partition the resources between applications and network functions, or how do you manage them? And also the who is going to manage the service? Like, is the application being delivered by a different provider, or is it delivered by the same operator who is also delivering the network service? Some interesting aspects to think about. But it's a very interesting topic. Yeah.
Okay, yeah, thanks. I agree on that. Here we just focus on the advertisement and discovery, but I mean, I fully agree that this is something that needs to be, I mean, for the actual services to be deployed, you need to have that. I mean, who is going to be the one actually deploying? So who is in charge? So, for example, what is the entry point for a service to be deployed in this case? And the different actors that are involved. Yeah.
Thank you.
Thank you, Carlos. So next two presentations are going to be made by the same gentleman, who's the one who's coming.
One
Here.
request to all, kindly pass on the blue sheets.
Yes.
There are two at this side and that side.
So let me ensure that we are. Yes.
Yes, I will make two presentations. One in my name, but also the next one will be in the name of a gentleman from China Mobile who couldn't come because of visa problems. And also just to mention that we tried to organize 4 separate presentations, more or less to elicit some additional feedback vis-a-vis of the new emerging, very important network slicing concept within the NAV environment. Also, just remind you, around a year ago in Chicago at the IETF, I made a big presentation and there was a lot of discussion vis-a-vis of options, how we can fit in network slicing in IETF concept. Since then, ETSI had issued 3 separate reports, more or less saying that this is feasible and important, but also currently all the other SDOs are issuing reports on this topic. Recently, I made a substantial effort to bring all the information available together vis-a-vis of network slicing in the form of a tutorial, which was presented 2 weeks ago in Montreal at a top conference on network softwareization. And the topics are there. And out of this, I felt that maybe it's a good idea to present to you a good shopping list of potential problems to be solved, not the ones which are potentially sorted out. And that's the scope of my presentation. Just to start again about the main concept of network slicing, which is presented here with many characteristics, is just to say that this is different from partitioning the connectivity fabric or connectivity and computing and storage fabric in a form of additional to these partitions will be required to map services and management characteristics into it as a unit. So to some extent, in that sense, network slicing is not new, probably it's as old as me, or even older, but on the other hand, it's a new emerging center of attention vis-a-vis of networking. And in that sense, a network slice has to be, like any type of network, self-contained, isolated, because we're talking about many parallel network slicing. It has to be programmed in the sense that you cannot just do it by hand configuring it. And to some extent, this concept is orthogonal to the infrastructure architecture which exists today and does not depend on a particular technology to activate as a data plane the partitioning, which is only one part of the network slicing. With this issue in mind, it's obvious that there is no point to think in terms of building new or deploying new services by creating a new infrastructure all the time. This is inefficient and extremely expensive, and is going to change substantially, potentially due to the advent of network slicing impact in the industry, in my view. Now, there are many ways to look at where this sort of concept could be used, and this is just a shopping list of potential massive user scenarios. I will point out only 3 of them. The emerging high-precision networks, which need to be created, bearing in mind that IP is not deterministic and also does not guarantee anything. So there is clearly a need to understand what to change in network functions and grouping them and how to bring them together with resource partitioning plus services in order to have specific guarantees for quality of service or KPIs. And you cannot do it for all the KPIs in the world or all the types of partition, all the issue related quality of service, but needs to be done per groups, i.e. per slice. And this is a key issue, for example, in defining very low latency type of network across. And this becoming an important topic. I don't know how you can do it without looking at slices. If you want to do it overall, it means that you have to redo the whole internet end to end. But there are many other opportunities to look at the way in which slicing could be adding value in user scenarios. Now, as I mentioned, it's already ETSI has issued different 3 documents actually, mainly as a white paper level about how network slicing can fit in. And this is a diagram which basically shows that how this may happen vis-a-vis of grouping network functions in addition to resources with services in a context of NFV. And this is an opportunity to move forward in a big way. Okay. Just to say that in terms of IETF, there were some around 10 drafts, individual drafts produced, some of them describing architecture, others which need to be looked forward. And this diagram shows one related to the framework in IETF for network slicing and one related to a research project related to how you slice a cloud. Now, I put together a longer list of problems still to be resolved, looking from outside in. And it includes around 20. Some are listed here, and in the area of multi-domain NAV network slicing, and there are different granularity. But also some related to other elements which need to be built and in order to ensure that the capabilities of network slicing in this context are realized. Some related to the way in which services and need to be mapped into this new concept, but very importantly, to look at the issues related to guarantees, slices with guarantees, either quality of service or KPI guarantees or scalability issues. We're talking about parallelizing the network, not in 2 or 3, but many tens of thousands of possibility in a dynamic way. Some years ago, NAV VPN was created, now everybody's using it. It's a time to think in these terms as well. So the question put forward is that these problems may be of importance to be resolved partially, not all of them, but some partially in this working group. And I'm looking forward for your feedback. Now, to conclude, I want to add one viewpoint, which says that people are moving away from NAV, centered around network functions, towards NAV centered around network slicing, which is at the center. This is a unit of networking, which need to be highlighted for different type of services. There are many around. I'm talking about network services, but they have to be supported by some sort of lightweight smart fabric as well as a coordinator. Yeah. So this diagram shows a slightly different view of NAV architecture, if you want, centered around slices, which are becoming the unit, or could become the center and a unit of NAVs. So maybe this will be triggering some thoughts. So it's a time to work on it, both how you manage it, but also how you bring it together in all the aspects. And that concludes my short introduction to this topic. In the slides, there are plenty of other references, including maybe 100+ references in academic world, plus another 20 from the SDOs related to network slices. Thank you.
Reza Rukui from Nokia.
Sorry,
Reza, yes. If you go back to slide number 4, there are a couple of things that, in the context of network slicing. First thing is, network slicing is an end-to-end concept. When we are talking about end-to-end, everything that we discuss, it should be starting from UE all the way to application. Anything else is not really end-to-end. And in that context, if we want to be pragmatic, in the picture that you put here, for example, is very simplistic. We have to consider distributed RAN, cloud RAN, C-RAN, on the EPC side, 4G, 5G. And if you see this one from end-to-end, not all the components are VNF. There is, for sure, there are PNFs, VNFs, and depends how you want to deploy. Do you want a virtual BBU, or you want to have the virtual CU or DU and the S gateway, P gateway, and so on and so forth. So one thing is, to me, if we want to have a real picture here, that should reflect not only VNF, but PNF as well. And it shows the concept of the end-to-end.
Yeah.
And
Reza, you're right, I agree. But I put the picture here mainly from Etsy, saying that they don't look at all these details underneath, but they should.
yeah,
Maybe in the
exactly. I
future.
mean,
Now-
if you want to address the, in 5G, you have to have, that concept.
Yeah, if you look at the bottom of this picture, it's somehow addressing your point. There's an end-to-end covering all the aspects here.
Yeah, it's a kind of, implicitly saying that, but this is very important because lots of people, that I
Reza,
work with
you are
lots
right. I fully agree with it. It may be that will add an additional set of problems how to create this unified end-to-end, but really end-to-end aspects. But we have to be also pragmatic to describe the infrastructure above, which is somehow independent on the legs.
Maybe I can work with you offline,
Yeah,
because I work on this one and we are really implementing it, right?
I'm
That's
just
also
worrying you
aspect.
that I'm not in line, or I'm not fully supporting the view that if you take one of these legs, do a slice there in a run, then applies to everything else.
No. Well,
Or
let's
to do another leg
yeah.
slice with VPNs, and then you do it. These are the complexity here.
I understand, but the one thing that you mentioned, and I really agree with that, network slicing, 5G network slicing is not VPN, is not LSP, is not tunnel, is much more than that. And this is whatever you mentioned. And this and one last thing, I don't want to waste time here. On slide 5, you mentioned about tenancy, and this is something that, in my opinion, is overlooked. The multi-tenancy that we are talking about 5G is different from hierarchical tenancy, or AKA nested tenancy, that we have in industry. And this is something that we can talk offline on that one, but this is something that I want to make sure that this is addressed, one way or another, because in even some contexts, people talk about network slicing. Whatever they talk about is really hierarchical tenancy. They overuse this word, in the different contexts.
You're talking my language, therefore wait until the next presentation.
Okay, great. So just a few points. Okay,
Right.
thank you.
Thank you. Any other comment? Okay. In this presentation, I have plenty of other information, another 20 slides, which I'm not covering, but at least. Anyway, this presentation was prepared by Liang Geng from China Mobile, but together with the other people, myself included, but he couldn't come to deliver it. And this focuses, presentation focuses on the, if you want, architectural elements of network slicing management, which need to be looked at in particular here. Just to recap the same concept, namely that the network slice is a set of infrastructure resources and service functions, very importantly, which need to be put together in order to serve the needs of a big industry. So as a role, as a concept, it's quite far-reaching. Now, slicing is a mechanism about creating such entities very easily across a data plane, control plane, management plane, service plane together. And in that sense, we have other players, namely slice provider and tenant, the ones which could be another operator or another operator or another company which takes over a slice or a number of slices and adds their own facility to it. So it could be managed by the initial provider's facility, but also they could be managed, if you want, and operated with additional tools and techniques of the tenant. So this is quite an important demarcation. Now, this slide more or less saying that this mechanism is quite absolutely essential, and to some extent is more important than the way in which, as a data plane, you activate the partitions. Because the end-to-end issue, as it was mentioned by Reza, cannot be resolved per leg of the component of the network, which is radio access, core, edge clouds on their own, let alone many technologies, many things. So it has to be, the mechanism has to be looked at the global things in order to ensure the usability of this concept at large. What this group was suggesting that two important interfaces need to be specified at length in order to exercise this slicing mechanism at large, end-to-end. One is about what is called the service delivery interface, which will be basically defined as a way to map service request into the container called the slice, and to activate it and so on. And that has its own complexity for end-to-end multi-domain situation. And the second one is about some sort of customer service interface, which is basically an interface to the tenant via which all this facility will be provided. And this is clearly needed. And another way to look at it is that they need to be mapped into the legs underneath, which means that the information systems and the information usage and the way in which are provided and the control elements have to be looked at together. So together, this is like an architectural view of the two critical points which need to be resolved. They are not resolved yet in end-to-end, but they could be. By the way, there are, my guess, around 10 or 20 separate architecture about network slicing in the research literature, research projects, and SDLs. So it's too much of it, and everybody is overdoing it. Clearly, it's a time to look at the granularity, which will have that in the context of being pragmatic. I don't see that I have more time, but this architecture more or less try to map tenants and providers with the orchestrator. The orchestrator is a system which is end-to-end, multi-domain, coordinator of all the activities which will make that happen underneath. In industrial terms, there are, to my knowledge, 8 separate big orchestrators developed now, open source. Some of them enormous, very difficult to configure on their own and so on. Some are lightweight, like the one developed at UCL, but they need to be put in a context. Orchestration functions are part of it. The type of resources and the information models need to be defined properly in order to ensure that whatever end-to-end slicing mechanisms are put in place need to be mapped into the separate underlying data plane infrastructure which will cover it. And this mapping is not straightforward and may involve many options. And this information system need to be better developed. Just to say that the two big interfaces identified are missing and the information model to be put in place. And this is one suggestion for maybe this group to look at in the future, if there is an interest. that concludes this short presentation about specific APIs which are identified as being of importance. Doesn't mean that others are not, but this is at least seen as of key importance to move forward. Thank you.
Reza Rukwi from Nokia. In my opinion, there is another model missing here is from the orchestrator to the network controller. And this is that connectivity API that it is something that again is missing here. We can, talk offline as well. So in my opinion, that is very important aspect from NSO that you put here to the network controller or network model. That interface is important. Why it's important? Because
this is not there already, because you have underlying network resources.
Yeah, you have, but the network resources today, everything works based on service-based. You say, I want to create a VPN from here to here and all the things. That connectivity is one level abstraction. That then interface that I'm referring to is a connectivity API. Again, to be pragmatic, that connection says, I want to connect eNode B to S gateway. I want to connect eNode B to UPF. It doesn't tell you which service to use and how to do it. That layer that basically takes that one, turn it to, that is something that
let's talk
we can talk offline after this. Yes, exactly. We can work together to, clarify that, but anyway, we can talk.
Thank you.
One request from the chats, besides offline, if you could bring the discussions in the group also will be much appreciated.
Yeah.
And also another thing to think about, I think the presentation on mobile WIMS and the discovery was very interesting. And I do think it's very relevant to network slicing, because today, if you look at slicing, it's still looking at more of a static aspect, right? So basically assuming that clouds are static, but you're trying to connect them, right? But versus the real problem is when resources are more dynamic, right? And then how do you create a slice in that dynamic environment?
Sorry, I was wrong. Yeah, I'm just, the suggestion here is to create slicing in a dynamic environment, both in the clouds and in a network. It's not static. They are not set up. Therefore, the issue is to do that on demand. And in case of clouds, more or less to have Vim on demand, something which was mentioned here last time, as a way to move forward, because it's not clear. Otherwise, if you statically configure a cloud and say, I want this Vim, that's impractical. And also the multi-domain aspects are, which was mentioned also in the other presentation, are having a bearing on this for the dynamicity of creating parallel slices, and as well as destroying them when the life cycle finishes. It is the challenge. It is a challenge, and it's also the second challenge is to build the system in such a way that will scale up to many, many thousands of virtual slices. If you can, there was I understand that some of the operators in China, chief executive officer mentions that they want to virtualize maybe 1,000 network functions in the next 5 years. The same thing here. I'm suggesting that we have to create a system which will virtualize or create these slices in tens of thousands as a target. It's not doing it one by hand. I hope that clarifies a bit your question, but which is valid. Thank you. I know that there are 2 other presentations in a row, so I would like to pass this message to the next one, which is Pedro, I understand, which will cover another aspect of slicing, and then Shuke will provide another aspect of slicing.
Okay, I am Pedro Martinez from the NICT Japan. I will present briefly what will be the roles and interfaces that are important for network slicing, especially in NFV systems. This is okay. Well, the context. The context is quite straightforward. We know that current networks are evolving towards deeper virtualization schemes. We are here for that, no? NFV is directly related to that. However, slicing physical and virtual resources in NFV is essential, as you know, for exploiting the capabilities. In this sense, we are with slicing that plasticity and composability provide benefits that must be incorporated also to NFV systems, especially in the future, because for commercial and in general organizational applications of NFV systems, plasticity and composability are a must. And of course, we have to consider also ubiquity in BNF hosting services like edge and fog computing that add additional flexibility to the whole system. So, and in general, apart from this, we can ask for improved isolation, scalability, and reusability, as we have also mentioned in this reference. Okay, so I will be brief on this. The technical viewpoints that we find in this scheme are two. First would be from provider to consumer, that as the view that providers have about the slicing mechanism and how they provide this slicing to the consumer. So in this sense, for example, NFV providers aim to maximize the exploitation of their resources, and so they slice their infrastructure resources to get the largest set of smaller resources. Okay, and in this way, both providers and consumer are concentrated on their own business. At the same moment, at the same time, from consumer to provider, the view is similar, but in this case, the NFV slice consumer, or like we can say here, the NFVO, like O coming from operator, I will talk about this later, aims to meet the requirements of the networks set by the application service provider, the final users, reduce the cost of ownership, be able to adapt the networks, etc., and everything as fast as possible, of course. So in this sense, what they do is to obtain a slice of resources. So they are their main business here, their main objective here is concentrated only on those slices of resources, not how they are split or how they are built on the lane. That's part from the provider. So these two viewpoints have to be, in some sense, considered when slicing NFV systems. Well, and here gives place the roles I have mentioned that are directly derived from these viewpoints. So I have talked about the NFV provider. It is the owner of the physical or virtual resources. I include also virtual because we can have some sense of recursivity here. Some provider that leases one physical resource and provides physical virtual resources to other operators. So as I have mentioned, this provider slices the infrastructure to get smaller portions, fast topology changes, and dynamically specific parameters. Okay, so it interacts with the consumers that I have mentioned at NFV operators to execute their requests, mainly create, read, update, and delete. So the main concepts are, as I have mentioned, managing the physical and virtual infrastructure and addressing slice requirement and improving resource efficiency and efficacy in the underlying system. In parallel, the NFV operator manages the slices of BNFs that he has requested on obtained from one or several BNF providers, NFV providers, sorry. Okay, I have this. Okay, so this is performed through the NFV controller. It's configured by this operator in order to execute these objectives. And as I have mentioned also, this can be recursively implemented, so we can have a hierarchy of NFV provider, etc. So, well, at the end we have the application service provider which establishes requirements to the NFVO. And then we can, as I have mentioned, we can have different variation of this instantaneity of the network. We have all roles can be played by the same entity or a separate entity, many combinations of them. So at the end, we have this, and those these are the roles, and these in green we see the interfaces that are are identified once the roles are interconnected one to each other. As we can see here on the right, we have some the recursivity I have mentioned. We can see that in this part. Sorry, in this part, and then more classic approach in this side with the provider, operator, and the application service provider will be the final consumer of this. So the interfaces are listed here, and that's all from my side. So if you have any questions, I hope so.
Maybe even faster.
No, I told you it was.
Okay, so
Next one.
next one, I guess, unless, well, just one thing is that if you keep using NFVO for operator, please don't. I mean, NFVO,
The dash, you have the dash.
yeah, but the dash is not.
No, but this is not.
No,
Okay,
be careful with that, because at the end you end up with naming very different things the same way, and it's. Okay, so, well, our next and last speaker is Shunsuke Homa. Thank you. Sorry? So here you go. Let me open it. 15. So let's-
Very okay.
Just 1 second now.
So, hello everyone. My name is Shunsuke Homa from NTT Laboratories. In this presentation, I will talk about the concept of gateway function for network slicing. So, firstly, I will talk about the motivation and purpose of the network slicing. Network slice gateway. The slice gateway is a data plane function to handle traffic for network slicing. So as you know, in network slicing, operation and orchestration is very important. Meanwhile, data plane functionality for network slicing is also very important. And slice gateway internet draft will be help to define capability of data plane function for network slicing. And slice gateway will be able to provide data plane functionality for providing N2 and network slicing across multiple administrative or heterogeneous domains. So this slide shows the overview of network slicing. Network slice is a logical network deployed based on service requirements. For example, for connected vehicles, low latency network is created, and such vehicles connected to the network. And we expect network slice would enable third parties to use network resources as a part of their own services. So this figure shows the network slicing life cycles. So tenant sends the service requirements to the network slice providers, and network slice provider receives the requirement and create network design, and convert the design to the concrete network configuration, and enforce to the bottom underlay network or server resources. And network slices will be created dynamically. And so the processes in Litbox will be very complex, and we would like to automate these processes. So this figure shows the rough framework of network slicing considered in COMS. COMS is both held in the last IETF. So network slice orchestrator receives the service requirement from tenant via CSI and SDI and convert the requirement to the concrete configuration and indicate to the underlay network resources via each controller. And network slices will be deployed dynamically, and thus network slices will be realized by using SDN and Nfvrg technologies. So this figure shows an overview of network slicing with Nfvrg architecture. So if Nfvrg architecture, we use an Nfvrg architectures, so some interaction between slice orchestrator and a network Nfvrg orchestrator will be required. So in some cases, for guaranteeing certain communication quality, end-to-end network slicing will be required. In this case, network slice subnet is created in each domain, and end-to-end network slices will be achieved by connecting such subnets. In this case, the orchestrator for integrating multiple domain will be required. So in end-to-end network slicing, there are several challenges. So for example, which information will be required to provide the controllability to the tenant, or how to synchronize the domains, and how to orchestrate each subnet. And in the data plane, there are also several challenges. So for example, how to detect traffic and forward the traffic to the appropriate network slices, or how to interconnect between the subnet, and how to keep isolation between or among slices to keep certain service quality. So for resolving such challenges on data plane, we would like to propose the slice gateway concept. So slice gateway is a functionality to provide some functionality for network slicing. And so slice gateways are deployed on each edge of subnet and provide connectivity or other functionalities for network slicing. So this table shows the requirements for slice gateway. So slice gateway will be required to some functionality in terms of two aspects. First is handling underlay infrastructure to create network slicing in the underlay network. And second is control services on network slices. For example, some tenant would require to provide several services on a network slice, and slice gateway will be an edge node, and thus some service control will be required for slice gateway. So on handling underlay infrastructure, so slice gateway will be required to provide classification to the forward the packet to the appropriate network slices, or some QoS control will be required to provide the isolation. So you can find the more detailed requirements in the original internet draft. So I will conclude my presentation. So for deploying appropriate end-to-end network slices based on the service requirements, definition of functionality on data plane will be required. And Slice Gateway will enable us to provide end-to-end slice across even multiple heterogeneous domains. So lastly, I will talk about the next step of this document. So we would like to obtain some more reviewing and feedback to the document. And we would like to break down the requirements to the concrete functionalities. And as you may know, so network slicing includes whole network system, operation plane, control plane, and data plane. So we need a dedicated group to discuss network slicing and in IETF or IRTF. So we will plan to provide both in IETF 103. So that's all my presentation. Thank you very much.
Okay. Yeah. We are doing extremely well. We have 9 minutes ahead of the closing of the meeting. So we have plenty of time for discussion, whatever you want to say. Related to Shunsuke's, related to Shunsuke's presentation of, since we have formally 9 minutes left, even we can open the mic for any further discussion that you want to have. So
I'll wait.
I have a bit of a provocative question, and I'm anticipating on tomorrow. There will be also a presentation on network slicing in the network management research group.
Yeah.
So I think I like the presentation that we're done today to give a different overview, different aspects that need to be researched in Nfvrg or elsewhere in IETF or IETF. What I don't really get is, if you want to have really a discussion on this topic, is do we want to have research aspects investigated in Nfvrg or NMRG on network slicing, which is the topic of today and tomorrow? Or is there also the attempt to still create one working group in IETF for this aspect? Do we want to have both? And I just want to have a bit more, anticipate a bit on the discussion and what we could conclude on those things. Because tomorrow there will be a session. I don't know if we will have time to discuss that also. But to know a bit more what the people are willing, what can really go into the research side, what can really go into the engineering side, it's not really clear to me today.
So it's my personal opinion. So the purpose of network slicing is provide service capability in the commercial networks. So I would like to discuss in IETF.
Just to add some comment about this question, there are a number of research elements which probably will take 10 years to resolve related to network slicing. And these research questions, the best ways to handle it in the IRTF. Some specific to management, some specific to other aspects. In particular NAV, which in my view is moving towards out of network functions into slice functions. That's my reading of the trend. On the other hand, as we can mention, and as mentioned by Shunsuke, this concept of slicing has all the elements related to the next level of networking, which means that there is an opportunity also in the IETF to dedicate a set of specific questions to be addressed in a group, rather than to spread everything into pieces as it is happen now. And in my view, that's a waste of energy and will not converge ever. Just to give you an example, a lot of people told me, oh, segment routing supports it, but the industry doesn't. But clearly, network slices doesn't depend on segment routing. It's about the use of services of the infrastructure underneath and the combination of it. So to some extent, to answer the question, in an ideal world, we should have a research set of questions in IETF, but also a dedicated, if possible, group related to the engineering aspects, which some of them in IETF, where other issues will be discussed. And this has to be arranged as best. But I'm personally not very keen to attach everything to an existing working group in IETF, like routing and so on, because they will get nowhere. Already I have problems about, well, what are these drafts appearing to do? Thousands of drafts which are not put in the industry. It's routing. So it's a big question in my mind. Anyway, I'm just expressing that in ideal world, this is how I'll do, but we have to be pragmatic in the next period how to move forward.
So this is another thought to add. Whether, I mean, with respect to research challenges, is it more of sort of solving building block problems? For example, you have input from different sources. Now, how you optimize, right? For example, placement of resources, right? Because that's one of the key problems you're trying to solve. You're saying it's a guaranteed slice. That means you shall be able to deliver that SLA, right? So is that more of a research challenge versus the interfaces themselves are perhaps, being standardized elsewhere? I mean, not as part of research. Of course, if there is some critical element, we need to think about it, but the standardization of the interfaces itself happens elsewhere. I mean, and maybe not even IETF, but some other body, right? Something to think about. Yeah.
Thank you.
Reza from Nokia. One thing that, to be again pragmatic, in my opinion, the first thing that we have to do, we have to define the API between the API that was missing in that picture. This is, to me, is very important. As we speak, we are trying to implement that one, and we can talk about that as well. This is something that, in my opinion, why the previous path wasn't that successful, this is my personal view, is because we didn't define exactly what are missing parts and what we want to do. For example, to define that API which was missing, you need a Yang model for the connectivity API. You define that, and that one becomes specifically in 5G. In 5G, the connectivity is a bit different from normal point-to-point, multi-point-to-point. Is related to that. So this is one practical aspect that we have to address that. The second one is the multi-tenancy versus hierarchy or nested tenancy. This is something that we have to do. In my opinion, again, that two model that you put there, that from tenant to orchestrator and from the orchestrator to the controller, that two model, they are important, but in my opinion, they are not that important, especially the one from from the portal, from customer. Tenant in this context is the customer, the BMW, I don't know, the city of Ottawa, BMW, Honda, whatever. So these are the aspects that if I want to do it, I start with those things, and we have to have a basic goal. Is network slicing related to existing VPNs? Obviously it is, but this is this is very important to consider implementation realization from the concept. The concept is connectivity with a specific SLA. How to realize that you can use segment routing, you can use ODU, OCH on the optical network, microwave and OTN, it doesn't really matter. So basically, a couple of things which is practical, in my opinion, we have to address it first. And if we do that one, I guess it's a good starting point. Thank you.
So we're almost on time. Maybe one last question.
A final reminder to sign the blue sheets.
Yes. Please,
Social.
if you have it. Thank you.
Any final remark?
I'm just
As
come
I
back
could
to
assume.
my final remark is that the world of networking is moving towards centering on slices as a way to deliver network services. If that's the case, then you have to readjust a bit in our thinking to look at it, and rather than to look at some piecemeal silo issues related to this topic, which is much broader in terms of usage. I suspect that 40 years ago when VPNs were invented, there were similar arguments, do we need it or not? But now nobody cares, it's using it. Therefore, we're at the stage where to use it. And I also add two key research aspects of this topic, which is scalability, large number, and also slices with guarantees, which are going to be the norm in the future. These are two subjects which may refurbish a number of architecture substantial, in addition to all the others, which are important.
I don't want to enter in an argument right now here, but let me remark, this group is focused on NFV. If we are going to change the scope, please, and this is a plea for opening this discussion on the list, please think about what has been said and discussed here, and if you can identify concrete research challenges or concrete research activities to be reported here that are related with NFV orchestration, network architecture derived from the application of NFV, performance of virtualized or mixed environments. I don't care whether this is a mix. That's our matter as well when we're talking about a mix, or which is the name? Yes, an heterogeneous deployment of physical and virtual functions. All of this is in our remit. And whatever the idea you feel like coming with, it will be welcome, and we are open to discuss it. This said, just let me close the meeting. Thank you so much. See you next time.